Hello and welcome to the Semiconductor Industry Association public webinar series where we discuss topics that impact the semiconductor industry. I'm Robert Casanova, Director of Industry Statistics and Economic Policy at SIA, and I will be your host and moderator for today's webinar on the US semiconductor industry workforce and the challenges and opportunities to attracting skilled talent. It is also my pleasure to introduce today's panelists. Dr. Loria Gordon, Assistant Dean at Jackson State University, Leigh Palmer, Executive Director at the Arizona Advanced Manufacturing Institute, Robert Geer, Workforce Development Lead at New York Creates, Tara McCoy, Workforce Development Lead at GlobalFoundries, and Dr. Kara Perry, Education and Workforce Development Co-Lead and Scale Program Manager at the Department of Defense. Before we begin, I would like to inform you to please provide your questions in the Q&A chat and not in the general chat. Just to give you a breakdown of the US semiconductor workforce, the industry currently employs 277,000 workers, and of that number, roughly 188,000 are in manufacturing. In addition, the industry supports 1.8 million additional US jobs. However, it is estimated that the workforce will grow by approximately 20% in the next 5 to 10 years, but attracting and retaining skilled talent will be challenging for the industry because of various obstacles, including the lack of awareness of the opportunities in the industry and competition with other tech sectors. With that in mind, I would like to turn it over to Dr. Gordon to begin the webinar.
Well, good afternoon. I'm Lori Brown Gordon, and it's my pleasure to share with you all on today as it relates to the semiconductor workforce space. And what I like to share is just some general information about populations that I have served in the HBCU arena and some outside as it relates to low-income first-generation students and students who come from underrepresented fields. And we have some programs, I would say, are some model programs that we have had some success in helping to create opportunities for those particular populations of students. We would say our Magnier Scholars Program, which is a program that prepares students for doctoral study. And we have prepared those students to go in various STEM fields. And then we also have our LS AMP programs, and they also do the same similar, but they provide a different set of activities for students. And then I serve as the Associate Dean of the Boys Harvey Honors College at Jackson State. And I've had the pleasure also to work with low-income first-generation students and helping them to identify career opportunities and choices and helping them to choose academic settings, academic opportunities to move them into those sectors. So I think as we look at some of the things that we've done with those particular and those three in particular programs and the high impact practices that we engage our students in is something that can be replicated and used as you look at, attracting the talent and retaining talent in the semiconductor workforce. And we do understand the manufacturing side. I think on the academic side, there's strengths in partnering with academic institutions to help with the research and development side, as well as the packaging side. So the high impact practices that are important to us, of course, is research. That's one of the first things that we have to expose our students to. And we have to do it in so many arenas. So why not do it in the semiconductor field? Why not expose them to laboratories? Why not expose them to mentors? Why not expose them to research experiences? And those experiences can be in industry, they can be at other academic institutions, and definitely they can be at our institutions. It's just about us creating the opportunity and creating the lab space or the right type of software equipment or the apps, whatever is necessary to expose students to what semiconductor workforce looks like, what opportunities exist. So I say you look at research and how we conduct research and how we can engage students at all levels in the research, from the undergraduate to the graduate. I think, just based on some of the other grant programs that I've run, that we need to start exposing students as early as high school to what the semiconductors. And I think, in light of COVID and all the things that have happened in packaging and shipping industry, I think the ears are open of all of these populations to learn a little bit more about what these chips mean and what they mean to us on a daily basis. Because I know if you take a cell phone from a teenager right now, we probably all be in trouble. So, that research is a high impact practice that I think we have to expose students to as it relates to the semiconductor workforce space and all the different components that's in there. Then the other piece I would say would be industry internship opportunities, whether they are virtual, because we're doing a lot of stuff even after COVID, we're doing a lot of things hybrid. So what kinds of things can we do to expose students? And a lot of times now, I in my honors college, about 10% of my students, I serve about 600 students, about 10% of my students change their major. 51% of my students come in as STEM majors. 26% of my students graduate as STEM majors. And I think a lot of it has to do with the fact that many of my students are low-income students or first-generation students, where the conversations at home are not about what's impacting the world at large, but the conversations are about become a doctor, lawyer, or Indian chief. And in my words, the Indian chief is a leader. So how do we expose students to the opportunities that exist in this field? How do we create opportunities for them to learn about the semiconductor field? So I think industry internships that include things like a mentor, and things that we can do, not just during a summer experience, but things that we can carry through maybe over a 2-year period. That's one of the things we do with our McNair Scholarship Program that found for us to be successful, was that we have a 2-year program for the students. The first year is focused on exposing students to research. So in this case, if we're talking about a semiconductor workforce, we can expose them to research in the semiconductor workforce. And then the next year, we spend time exposing students to graduate programs that fit the fields that they're going into. That includes visits to those institutions. So yeah, we need to make sure that students are exposed to labs, different types of labs in different locations. The first generation students, oftentimes, they've not left their state. Some of them haven't even moved outside of the city from which they are from until maybe coming to college. And so those are some of the, I would say, social and cultural experiences that can happen, so that once we move students into a new field, expose them, provide them access, provide them mentors, involve them in research, then we also have to look at what does that look like socially and culturally, because research will tell you that oftentimes first generation students don't typically move far away from home. All right, so those are some of the things that we've done through our programs to catapult students into other arenas. I think those are some things that we can do to help students, to expose students to the semiconductor workforce. I also believe that minority students, underrepresented students, and low-income students are a population of people that need to be served in order for us to actually grow the industry. Those are people who have not been exposed. Those are people who don't understand the intricacies and all of the opportunities that exist in the field. So how do we move communities? How do we move people? We move it through access and opportunity, involving them in high impact practices, and addressing also the social and cultural exposure pieces that are necessary for them to be successful. I think those are pretty much some of the things that I think are necessary for us to work with our various HBCU institutions and probably some of the others, but identifying some of our model programs and replicating those kinds of things toward this particular industry. So we know LSMAP is doing well. I know McNair is doing well. I know that for my honors college members, we do one-on-one with them. We work with the students in completing career assessments. We work with the students when they start looking for internship opportunities and experiences and research. We work with them to identify mentors for them. We work with them when we find deficiencies in their academic issues so that they can apply for something like semiconductor research experience with any of our institutions. So I think that kind of sums up where I am, and I'll be glad to share a little bit more information a little later. Thank you so much, Robert.
Thank you so much, Dr. Gordon. Next, we will pass it over to Leigh Palmer.
Hello. Thank you, Robert, for sharing the slides.
One moment.
Happy to be here. So much good news in the semiconductor space, in seeing all of the magic that happens in the fabs and in the work of semiconductor. What we've realized at the Arizona partnerships that we've been developing directly with Intel is that we have to build this pipeline together. There is no way that you can come in with solutions that aren't directly intertwined with industry. Next slide. So one of the first things that we did was realize that we needed to, both for scope and scale, look at this partnership as it was college-based, that it was regionally focused, and that it was specifically sector-driven, so that all of those skills that could be drawn upon in many other industries that are baseline could actually now have the focus of semiconductor. And so with Intel, we started our partnership with an intentional model and made a letter of intent so that we could declare both publicly and professionally to each other the things that we were going to do: mapping skills and competencies, sharing materials and costs, recruitment strategies jointly marketed, and explained that the opportunities available for the eligible candidates would be hired and go through a hiring process directly with the semiconductor companies, Intel and those in our advisory. Next slide. So the development steps really for us was modeled after a partnership that we had been doing with aerospace and Boeing. And that was that in order to meet both scope, which was the targeted skills that were absolutely critical, not every skill, not just really good skills or the bulk of skills, but what was absolutely critical to make them come in the door and begin to be able to be productive. And so what we did together was define our mutual needs. Having a strong base in your technicians' roles was critical because that's going to be the launch pad for multiple job roles. Also, the action plan that we were developing had to be integrated so that we had everyone at the table, the faculty. We had to have the training arms and the development arms of Intel, joint marketing teams. We had to have action plans that were about strategic pipeline management and dealing with diversity, equity, and first-generation college goers to reach populations that were traditionally not going to be reached or didn't see themselves in this work. And then implementation. And just to give you a kind of what the lens looks like currently, our implementation is our beta and first cohort is going to be this May 16th. So we'll have lots to share as we see this unfold. And then assessing the data and refining our processes based on that data. I'll show you some of the data measurements that we'll be using. And then finally, celebrate and replicate, which we all look forward to, because the investment of both time, energy, talent, and resources has been significant. And in order to create this an improvement, continuous improvement, we want to be able to have that reflection and celebrate. Next slide. So with this regional approach, Maricopa, which is a very large county, has 3 community colleges working with Intel and with TSMC and with 15 other semiconductor companies and suppliers. And we're putting this Quick Start program together, which is a 2-week, 10-day curriculum that is hybrid. It is driven by the competencies that were of most priority, both to industry and capable of being driven at the colleges with the resources. We have developed $2.5 million to date dollars from our state and foundation funding and Intel support with providing tools, equipment, and supplies. And we have an acceleration scope designing the 2-week boot camp belonging to a pathway so that they not only earn college credit for this and an industry certification, but this also belongs to a greater pathway of industrial automated technologies, which is then the tooling and machining and repair technicians in industry. And then we're going to be sharing our data and the matriculation and the benchmarking and the refinement of a student all the way from attraction to enrollment to completion to hire. Next slide. The design is that we meet weekly, and some teams like marketing meets twice a week. We have jointly identified the equipment and supplies that are replicated in the industry and meeting industry standards so that we're having that in the classroom and in the lab. We have Intel recruiters that are going to be visiting each of our classes every month that are going to be doing on-site career fairs and hiring at the colleges. We're doing interviews that are conducted monthly on the campuses that are directly related to the logistics of the students that they serve. And adjunct faculty, we have recruited internally to Intel. We had over 140 interested in becoming adjunct faculty, and we have now interviewed and cleared 49 of them to teach these 2-week boot camps directly from industry. Our joint marketing includes collaborative landing pages so that no matter what door they open, it leads them to the process of a pre-assessment. Videos, sharing, we have Oculus headsets that we're using to attract and use content that is specific to show the magic that's happening in the fabs, which is very unfamiliar to a lot of people. And then the metrics, we're looking at increasing women technicians, highly targeting veterans, and our diversity and equity is of high value, and then keeping it in this accelerated model so that we can get scale. Next slide. This is the systems pipeline data that we're looking at, and you can see that we are tracking first generation college goers. In this point with our Boeing boot camp and aerospace boot camps, we're showing 65%, I believe that is, or 55%, excuse me, first generation college goers. That means that by offsetting tuition and making this cost neutral, having it accelerated so they can change their shifts or take vacation time or find daycare to attend, that we are actually attracting those that have never been to college. And the beauty of this is not only do they leave with a portable industry certification, but a college transcript and a feeling at telling the people at their dinner table, I have gone to college. We have a quite diverse age range and age group. Our gender female to male ratio is increasing at times, and in classes we have up to 23%. And our veteran population is being tracked. And over our programs that are in this accelerated format, we're seeing almost 12%. Next slide. We built this with an advisory board. They all weighed in on the curriculum, the acceleration, the place in which their company needs these particular skills, and that they want to take this baseline entry-level semiconductor technician and grow them to become their next level semiconductor with multiple job roles that this blends into. Next slide. Impact and benefit. Currently, we opened the gates because Jill Biden, the First Lady, came and gave some spill light or attention to the program, knowing that we were launching this massive industry-driven accelerated program. And from that point, which was just 3 weeks ago, we are now, this wait list of 300 is actually now 391. We have had 372 that have actually passed the pretest, And our Intel managers and classes are all going to have the culture shared so that they're dealing with what we call employability skills. We're having recruiters that are dedicated to the hiring to answer questions and help with application processes. We will have a dedicated requisition so that those going through that requisition are identified as boot camp graduates or quick start graduates. And the ACRC is a state-driven employability training and testing for situational awareness in the workplace, basic reading, math, and navigation for information skills, such as can they read charts and graphs. It's important that they have that acumen to be successful on any job. And so we're giving them that opportunity during this boot camp. We're also having the first of its kind industry NIMS certification for entry-level semiconductor pre-apprentice that will be part of the rubric for both their grade and their portability with all of these skills that they'll be able to take to any semiconductor industry partner. Next slide. What I want to say is that the Quick Start Building New Model program was really about having targeted competencies driven by industry, having industry blended throughout the entire process, including the classroom. And in addition, I think that the attraction to this model being accelerated has brought in a new population into the manufacturing sector with new diversity and equity opportunities that allow them at a cost neutral place to participate. Thank you.
Excellent. Thank you very much for that very insightful presentation. Next, we'll pass it along to Robert Gear.
Thanks so much, Robert. My name's Bob Gear. I'm from the SUNY Polytechnic Institute up in very warm, balmy New York State. Yes, 24 hours ago we had snow on the ground, but it's gone now. So we're all happier. I want to talk a little bit about you know, the academic industry side of partnerships and really what we've been doing here in New York State. You know, we have a number of semiconductor manufacturers, and just like everyone else, supporting that workforce is a significant challenge. So, you know, we've seen the same type of you know, key recipe that I think everyone else has. You absolutely need to address the entire spectrum of the people you put in the workforce. And not only the academic spectrum, you know, from 2 years to two-year students or two-year degree students to PhDs, but you have to be able to engage, you know, transitioning workers, people coming from adjacent fields, you know, how to give them training and how to impart skills to people that are currently in the workforce. So we have been developing partnerships, for more than the last 2 decades, and to do this. And our focus has been using industry scale shared facilities that have been really supported by industry, federal, and state government. In other words, really a place where our students can come, you know, from across New York State and develop the skills they need. So one of the things I want to talk about a little bit here is the nature of the facility. This has been developed, you know, in long-term partnership with IBM, TEL, Applied Materials. We've been a long-standing partnership with GlobalFoundries from when they were AMD, as well as some of the newer folks, Wolfspeed and Cree, who've built a small fab out in central New York. And we focus on a facility that has access to a full 300mm silicon process line. This is done for R&D and develop and so forth, but it's also a tremendous workforce tool. And as we look forward in terms of ways to engage people, and I think both Gloria and Leah have really you just hit the nail on the head in terms of making sure there's awareness and people understand what these careers are. This is a tool that's been very important for us to use. We've also recently expanded the area of packaging. And listen, silicon fabrication is key. Packaging is becoming more important. And there's just not a strong US presence in packaging. So one of the areas that we've done is to try and leverage these facilities, these partnerships, you know, having people from manufacturers that are really sitting, you know, across the hall from me and leverage their experience, work with industry associations, not only SIA, but of course SEMI. And what we've done is try and take that and use this as a way to distribute content across a number of institutions here in New York, because that's really key. As Leah pointed out, getting the right competency and skill training to students, whether they're 2-year, whether they're PhD, is essential. And so one of the things we've been doing is leveraging the capabilities we have to provide that sort of content. So much of it is hands-on. Skills that you really need able to hold things and touch things to put them out. And we've distributed those to our community college partners, to our university partners, our college partners. Likewise, being able to access, for the people on the engineer side and the design side, access to what are called multi-project wafer runs. Actually, the ability to design and submit a design to a fab so that you can fabricate it. Not a trivial thing, using industry logos such as process design kits and CAD tools, but that's something we do in some of our outreach programs. Likewise, experiential learning, something that's really important for us, that is getting these hands-on skills. The facilities that we have, we open up for that. And I'm sure there are, if not fab managers, certainly people familiar with fabs listening. It is not a trivial thing to open up your facility to people that come in with little or no experience. But that's been a focus of ours, because really to populate our own workforce here, we've seen that as essential. So bringing people in so they can get that hands-on experience, not only for their skill development, but also for their awareness, because every successful person you bring in becomes someone that that advertises and markets in their networks, regarding careers. And come our worker training, what we've seen in a number of our partnerships is you just can't stop when the students leave your institution. Updating skills, bringing in people from adjacent manufacturing sectors. It's all critically important to support the semiconductor pipeline. And that's the type of programs we've been working on with our manufacturers, GlobalFoundries, Tokyo Electron, Wolfspeed. It's really critical and really important to be able to keep that pipeline full. Workforce pipeline expansion. This is something near and dear to our heart. We focused a lot of effort on working with veterans, something that you've already heard today. But it's a key demographic, because not only do they have the skills already, but to be honest, they're not very aware of career areas in the semiconductor field. So I do want to talk a little bit about experiential learning. As I said, we've opened up our fab. And it can be a concerning thing to bring a 2-year college student in, but we've been doing it for several years. It really is a key for us to support our workforce. And we think it's something very scalable as more and more of these types of really advanced university and college-based facilities come online. We've had 75 interns over the last several years that have gone through and spent, really 3 months working in the fab, becoming a level 1 process operator, as we call them. And that's been a huge success for us. Very important to support our own workforce. And we've been expanding that to the 2 other sites in the US, most notably to the clean rooms at NIST in Gaithersburg, Maryland, and the Air Force Research Lab in Rome, New York. So being able to get students engaged is the best way to have them follow that career path. And transitioning students is one of the hardest things to do, from course of study to actual jobs. One of the things that is really, as I said, near and dear to our hearts, there are 200,000 US servicemen and women that transition out of the military every year. That's a tremendous workforce, and they are used to working in complex fields, in complex organizations, task-based work, and they're a gold mine. But it is a challenge, and then from everyone I've spoken to, it's a challenge across the board. So really, we've been working with Fort Drum, which is a Army base in northern New York, to focus how do we best engage transitioning veterans, not only what skills to give them, but exactly how to bring them into these fields, because most of them are not familiar with this. And so we spent the last 4 years developing this, and it's now a full-fledged skill bridge program. It's called VetStep, for Semiconductor Training Experience Program. So we put them through a training of 96 hours and over the course of 2 weeks, and then moved them through into an 8-week internship with chip-based employers in our region. And that is a program that we've just started. It's out of Drum. We're marketing it to other bases. But this is really, for us, a way to work on that pipeline directly. And it's all hands-on based, and we feel this is a good model and can absolutely scale, considering the number of colleges and universities that have clean room-based labs that would be perfect for this type of training. So, and I would be lying if I didn't say that we wouldn't be doing this if our employers in this region weren't pounding on our doors saying, okay, we need more workforce, we need skills. And that partnership, those partnerships have been incredible. I know the folks at GlobalFoundries have told us, just time after time, these are the skills that are critical for us, help us get students these skills. So over the last several years, we've been building piece by piece a network. And as we see more, across New York State, and I just illustrate a few of them here, and as we see more, resources being primed to address this issue with the CHIPS Act and USICA, we think the time is right to take some of these models that you're hearing about now and scale them. You want impact across the board. There's a great number of people out there with a lot of skills, and the key is to get them into this pipeline, for semiconductor manufacturing. So with that, I'll turn it back over to Robert.
Thank you, Bob. That was a great presentation. And with that, we'll pass it over to Tarat from GlobalFoundries.
Sure, I'll just need to share my screen here. All right, are you able to see that? See if we
Yeah.
get the slideshow started as well. All right. Hi, everyone. I'm Tara McCoy, Workforce Development Lead at GlobalFoundries. You're going to hear a lot of similar themes echoed in my presentation from what we heard from our colleagues earlier. The focus I'm going to talk about today is the business education partnerships and how important it is to invest in those to enhance our talent pipeline. At GlobalFoundries, we focus on the entire pipeline from the K through 12 through apprenticeship, internship. I'm going to talk to you a little bit about our online resource, STEM at GF, and what we do a little bit for internal talent development with our business education partnerships. So first of all, why would we want to engage this early? The reason is, at the elementary and middle school level, we can inspire excitement for STEM. And these students are the students that are going to be our future workforce. So we engage throughout the whole K through 12 pipeline. The conversation changes from inspiring excitement about STEM more towards the pathways to a career in semiconductors at the high school level. The unique model we've come up with to help with this is an ambassadors program. This is a group of enthusiastic employee volunteers with a passion for STEM outreach. And what they do is they engage with students throughout STEM programs, career fairs, and more. So you can see here, bunny suit try-ons are always a good hook. Playing with snap circuits at a STEM expo, or talking to a high school class and giving a presentation on the semiconductor industry. So we hope that by engaging with students early on, especially in Malta, New York, where we're located, that students will start to understand the opportunities available right in their backyard. We're very excited to have launched a maintenance technician apprenticeship program recently. This is designed for people to come in with no previous semiconductor experience. So somebody coming out of high school who's 18-year-old and has that diploma or equivalent, and that has a mechanical, hands-on type of aptitude can come in and learn on the job while they're getting paid full-time. We've partnered with Hudson Valley Community College to take 4 college courses over the course of 18 months. Those college courses are covered by a grant, and so the training is at no cost to the apprentice. So it's win-win for them, for the apprentice that comes in. They're learning about a new industry, they're getting hands-on training, and they're getting courses that they can use towards an associate's degree if they wish to pursue beyond the apprenticeship. This is a registered Department of Labor apprenticeship, and was supported by the Center for Economic Growth as well as Hudson Valley Community College. At the community college level, we offer a technician internship. So between years 1 and 2 of an associate's degree, students can come in and get a full-time paid summer position with GlobalFoundries, gaining valuable hands-on experience, while also giving us early intel onto our hiring pipeline. We give those students an option to continue part-time for the rest of their year 2 as a paid position. And we're very flexible with their class schedule so that they can finish that degree and keeping a foot in the door here. Providing a lot of networking and training, which with, of course, the goal to convert to full-time before graduation. And so this is a great way for us to get that early intel. It's kind of like a long interview process for both parties. And we've seen some really good success with the technician internship program. Of course, you're all familiar with the internship programs that one does at the bachelor's and master's degree. It's quite similar in terms of being a full-time paid summer position with also that option to continue part-time as a co-op. And again, with that goal to convert to full-time before that person graduates so that we can grab that talent early. One of the things that we recognized, and I've heard this theme echoed quite a bit, is the awareness of what semiconductors are and what kind of jobs there are. So during the pandemic, we were looking for a way to stay connected virtually with our schools and our education partners. So what we did was we created a web page right off of gf.com, and we named it STEM at GF. And what we did was we focused on putting together some engaging videos, the inside of a clean room, how chips are made, some animations, as well as some hands-on K-12 activities that kids could do with household items during the pandemic. Most importantly for us is getting the word out about what are the many pathways to careers at GlobalFoundries and into the semiconductor industry. So that page really lays out, what can you do with a high school diploma? You can come in as an apprentice. What can you do if you're getting an associate's degree? You can come in as a maintenance technician. And what kind of engineering degrees are we looking for? We're looking for chemical, electrical, mechanical, industrial, and more. So we feel that this has really helped kids and especially schools and teachers understand the many pathways in, that there's not one formula because we need to reach out further than that. And so this has been really helpful for us to stay connected with that community. The other aspect of our partnerships with our education partners, many of the community colleges and the local universities in our area, we have a Fab Degree partnership with. So alongside tuition reimbursement, which I'm sure you're very familiar with, where an employee can get reimbursed for any tuition that they incur to pursue a degree while employed here, we have partnerships set up where employees can get additional benefits from our partners. For example, there might be an offer of a discounted tuition or a waived fee. This is really important for our technicians, a shift-friendly schedule. So the classes could be offered on the first half of the week so that if the person is working on the last half of the week, they can do both. Another really important aspect has been deferred billing. This has been really attractive for our employees to not have to pay out of pocket up front, but to get reimbursed at the end of the semester and then be able to pay that bill. So, this isn't the only thing by far that we do for our internal development of our employees, but it is a way that we have strengthened the partnership that we have with our local colleges and universities. So the employee benefits because they can see that the business is investing in them. The business is benefiting because excuse me, the business is getting the additional training of those employees and able to flourish more under that. So it is win-win for everybody on that one. And I wanted to bring that forward to your attention. So that's just the recap, being that we are focused on the entire pipeline from K through 12 all the way through our employees that work here. And I will say that it does take dedicated resources to be able to pull these things together. I think, before the pandemic and before all of this explosive growth in the semiconductor industry, this type of work tended to be on the side of somebody's job, maybe somebody in the communications department or so forth. But it's become more important than ever to really dedicate resources to this, full-time positions, or carving out a significant portion of someone's job to push these things forward. So that's my final thought that I wanted to bring to everybody, and I'll pass it off to the next person. Thank you.
Excellent. Thank you so much, Tara, and we'll end with Kara, excuse me.
Thank you, Robert. So today, what I thought I'd do is I would highlight a successful workforce development program that the DoD has funded with seed funding to get it started. And if you can go to the next slide. I think that everything that I'm going to say here has been repeated in previous talks. A lot of the ideas are similar to what's already been mentioned today. And the idea between this program, first of all, it's called SCALE. It's the Scalable Asymmetric Lifecycle Engagement. And it is a public-private academic partnership that has been created to develop this workforce in microelectronics. And the method that we've used to create this is to define a program that would be all of those things at the bottom of the slide. So we wanted to make sure that the program could be scalable. In other words, we want to be able to expand. We're going to start with a small number of universities and expand that to a larger university consortium. We wanted to make sure it was replicable. So right now we have 5 technical areas that we are focusing on, but this can easily be expanded to additional focus areas. Another key part for the DoD, of course, is that it's asymmetric. We want to make sure that we are producing clearable, knowledgeable workers. In other words, a lot of the DoD work, and even in the defense contractors, the students or the workers need to be able to receive clearances, and so that is an important part. So all of our students that are associated with SCALE are US citizens. And then, of course, this is nationally coordinated, but regionally executed. So for example, if we create a special course at one university, we're going to expand that and teach that at all the universities across the US. And then the students frequently are going to stay in their region and work at local companies. So that's why it's important that it be nationally coordinated. You're teaching the same thing to everybody. However, it is regionally executed. So next slide. So a little more detail about the program. And as I said, it's a public-private academic partnership. So the way that we approach this, again, similar to what was mentioned earlier, is that we talk to all the stakeholders. So in this case, what I'm talking about is the government agencies, which includes DoD, NASA, MDA, Sandia National Labs, et cetera. And we also talk to the DoD contractors that are going to be hiring these students, and did a needs assessment to figure out what knowledge, skills, and abilities the students need to have to be successful in these career fields once they graduate. So taking that information, then that was fed to the university consortium and converted into curricula, mentoring, internships, and other activities for the students to learn from. So a large part of the program, right now we've been focusing mainly on bachelor's, master's, and PhD students. However, this, as I said, is expandable to include community colleges and existing workforce. So right now, what we do is we have taken the needs assessment, converted that into specialized curricula and research projects for the student, whether it be a junior, senior project, or maybe a PhD thesis. Along with internships, we have a large number of companies and government agencies that are involved with Scale that hire these students during the summer, where they can not only receive mentoring, but get hands-on training and also see what types of careers they can have in these fields. So you can see here that we have currently 5 technical areas, and radiation effects, advanced packaging, system on a chip, trusted AI, and supply chain awareness. And those 5 areas, as I said, can be expanded to additional ones in the future. So we have this university consortium, and each technical area is led by a different university, and the entire consortium is led by Purdue University in Indiana. And of course, there's advisory committees that we have for oversight that, again, make sure that we are still meeting the needs as we go forward. And of course, providing data-driven recommendations for this effort. So next slide. And really, this was to emphasize some of the success that we've had. This project started in FY20, and as of February 1st, we have actually breached our 5-year goals only after 2 years. So we have over 200 students in the program right now. We have over 50 government agencies and defense industrial base companies who are participating in providing internships and sometimes senior projects, etc. And then right now we have 16 universities. Of course, we'd like to expand this to additional universities, and we are hoping to do that in the future. The number of internships, of course, some companies don't know exactly how many internships they're going to have available next summer. That's why there's a large range there. But we're going to have anywhere from 145 to well over 200 internships for these students to apply for. And we've created 10 specific courses for these students to take. Now, a lot of universities already have relevant curricula, and of course, the students are taking those courses as well. But in addition to that, we have specifically created courses that are relevant to what we determined from the needs assessment and the skills that were determined ahead of time that those students need to receive. And the last one I wanted to mention here is, we've talked, previous speakers have talked about, reaching out to students and how do you get them interested in microelectronics. And so one of the things that we've done is a pilot program at Purdue where we've taken a first-year engineering course, which is required by all engineering students to take, and we've inserted into that microelectronic problem statements so that the students, even if they weren't aware of microelectronics before they took this engineering course, they've now been exposed to some problem statements and projects related to that topic. So hopefully that will help them get engaged. So again, this project so far has been pretty successful. We've been able to use this public-private academic partnership to train the students and give them the knowledge that they need so that they can be successful in these areas. And if you go to the next slide, it's just a summary of everything that I've talked about here. And I'll leave it there.
Thank you so much, Kara. So now we have time for Q&A, and I would ask that everyone please type your Q&A in the chat function, in the Q&A chat function, and not the general chat function. But just to get the conversation going, I do have one question that I'd like to ask everyone, and I hope that each panelist can answer. So when we're talking about the industry, which do you see as the most important barrier to getting students into these career paths? The first being building the foundational skills via training and curricular, or building awareness of the industry and the different career pathways, or building the professional identity of students as they enter training in this field. And I'd like each panelist to please give an answer of which one you think is the most important barrier and why. And we'll start with Dr. Gordon.
Hello, I'm going to say awareness from my perspective and students' knowledge base of the field and the opportunities that exist within the field. I think that's going to I think it's just critical. And as we talk to students, and I'll go back to my statement earlier, students coming in and they want to be doctors, lawyers, or Indian chiefs. Those are leaders. Those very common roles that we know about. They don't understand that there's so many other things that they can do in STEM majors. My students who come in and want to be engineers, they don't know what kind of engineer, but they may choose electrical engineering or computer engineering, etc. But they don't really know the intricacies of the career opportunities that exist. So I'm going to say awareness right off the top.
And Leah, would you like to provide an answer?
Absolutely. I think that some of the difficulty that we are trying to address specifically is the fact that most of the population that comes into the community college has no idea the different job roles or the opportunities within semiconductor. They just see these huge buildings with no idea of what's happening inside. And for us to be able to highlight that there is not only spaces and places for them to thrive and use their strengths, but that once they get in there, they're going to continue to grow and find other ways of contributing to this part of the industry. When they connect what happens with the chip and how it's made and all of the technologies that are driving what they love and do in the world, suddenly they have a relationship with it. But until we can make those connections with them and for them, it's very hard for them to think that a job description is going to let them in or that they're going to be qualified to do something that significant.
Thank you. Tara, do you have an answer?
I would echo that it's the awareness. So at the engineering level, we have kids going through engineering school, maybe not even aware of the semiconductor industry. Chemical engineer, electrical engineer, they can go almost anywhere and they may not know that semiconductor is a choice. And then to echo what Leo was saying about the associate's degree in the community college, again, the kids they don't see that they could be working at a place like GlobalFoundries because they think it's only for engineers and PhDs. They don't realize that a third of our workforce is technicians. And it's the key to keeping all that high-tech equipment up and running smoothly. So it's getting that message out there that the hands-on mechanical skills are super important.
Thanks, Tara. Bob, how about you?
Yeah, sure. On the skilled technical workforce side, 2-year degrees, absolutely, it's awareness. People just aren't familiar with with what the career pathways look like. So, Leah and Tara hit it on the head. For the higher level, it's a little bit different. There are more STEM degrees offered in the US every year. It goes up around a 2% clip. For those higher level degrees that support the semiconductor industry, electrical engineering, similar, they're actually going down. And it's become, for students, they see ways that they can innovate in other areas. And they sort of lost that for how they can innovate on the semiconductor side. So while, people have been going just into machine-based learning, robotics, everything powered by semiconductors, you had fewer people going into the semiconductor industry. A couple of years ago, I think 2019, if you're familiar with FIRST Robotics, it's a middle school, high school robotics competition. I think they had 40,000 people show up for 1 week finals in St. Louis. It's kind of hard to find an analogy of that for the chip industry. So being able for the chip industry to show people how they can innovate, how they can have a social impact, at that design, higher end R&D level, I think that's really critical.
And Kara, would you like to provide an answer?
Sure. I of course think that they are all important, and it's tough to pick one. And as I mentioned in my presentation, we do spend a lot of time trying to make sure that engineering students realize that microelectronics is a career path and that they're aware of it. But I think that I'm going to add to, I think it's really important that the students are able to see themselves in these particular jobs. And I think that's difficult. I think that a lot of students think I don't have the skills, I can't do that work, so I'm just not going to go into it. And so I think that the student self-efficacy is very important.
Great. So, we talked about attracting or providing that awareness to attract professionals into this field. What would you say would be the biggest obstacles to retaining the talent once you have it? If you have an engineer that you've trained and now they see other opportunities in other tech sectors, what do you think are the biggest obstacles to keeping them in the semiconductor industry? And we'll start with you, Tara.
Sure. Well, first of all, I think a lot of the attrition that is seen in the semiconductor industry is just a revolving door to other semiconductor companies. That's definitely a big component. When we've always seen that throughout the semiconductor cycles, ups and downs throughout the decades, but nothing like we've seen today. And you're right, the FANG companies, the Facebook, Apple, Netflix, Google are definitely a competitor in terms of the flashiness of those types of jobs. So that's definitely a challenge. But I think where we can do better is providing a better work-life balance for people. Manufacturing is hard. Manufacturing requires 24/7, 365 days a year. So if we can identify ways to promote better work-life balance and advertise that, I think that can go a long way.
Thank you, Tara. Kara, do you have an answer for this question?
I do, and we have the same problem. We want to try and get students interested in working for the DoD or the defense contractors instead of going to Apple or Google. And I think that's why we highlight the internships so that they can see the important work that these companies are doing and the importance of the projects that are being worked on. So I think that really is the important part there, is making the students aware of the impact that they can have if they're working for the DoD or the government.
Great. Leah, do you have some insight on this question? I think you're still muted. Well, we'll go to you, Bob, and then we'll come back to you, Leah.
Well, sure. I'm, not an employer, so the industry still has the same issues that almost everyone has now. There's a huge competition for people, but the industry has grown practically every year since the early 70s. So being able to let people know that maybe there is no such thing as a lifetime job anymore, but there's certainly a lifetime career. And in the semiconductor industry, you can, really attack so many different problems in so many different ways. It's innovation from start to finish. I think it makes sure people know that, they can find so many different avenues to grow their career in one industry. It's important for the people going into the industry, the folks that I see, for them to understand that.
Great, thank you. Loria, do you have an answer you'd like to share with us?
No, we're not employers either, but we do get them out there. But as I listen to the question, you think about Generation Z and how we advertise and how we share information with them. And I think it's important that we give it to them the way that they understand it best, and that's through social media. How do we put it out there so that it's in jargon that they understand, and help them to explore the opportunities that could move their lifestyles forward.
Great, thank you. So one last question before we end. For those companies in the semiconductor industry who haven't been able to create these partnerships, and they want to start, how would you propose starting these programs, these partnerships? And we'll start with you, Bob.
Well, sure. For us, especially the companies in our region we work with quite a few other customers or partners. Reach out to us. The network is broad because it's not just our institution, it's the institutions we interact with across the country. Whether it's through federal resource agencies like NSF, whether it's through professional organizations. And usually you'll find people on the education side really anxious to work with employers to get our students positioned. Sometimes we just need someone saying, hey, I'm here on this end to help if you need it.
Great, thank you. Leah, I think you have your sound back. Do you have an answer to this question?
Yeah, I think that there has been a mindset for a long time that the talent gets trained, the trained apply and go out into the workforce, and then the workforce decides the best of the best and who they're going to bring aboard. I think that the shifting in tides now is that industry is much more integrated now in the preparation and the willingness to look at the potential workforce in a different way. And so when you look at a lot of the breaking down of the competencies that someone has, whether it's electrical, mechanical, or tooling, or fabrication, or lean, some of these things, there are people who are working on other fields that have those. So finding a way for those transferable skills to be able to be valued and mapped and part of that application process, that when someone sees the job description, they can actually see themselves capable of doing that. This industry in semiconductor is going to get a lot more individuals who see that this is something that they can do. Otherwise, it's not transparent, I guess I can say. So I think that there's a lot of skills out there that we just need to repackage and then let semiconductor be the answer.
Great. Thank you so much. And I'd like to thank all of our panelists. We're at the top of the hour. Thank you all for the great conversation on the U.S. semiconductor workforce. And for the viewers, the slides and a copy of the video will be posted on SIA's website in the next couple of coming days for you to view. Thank you very much for everyone for the discussion, and that's the end.